Hey, g'day, it's Prezzo here back in the shop, and I have a bit of a confession to make. Some time ago I posted a video showing an upgrade that I was doing on this DIY spot welder. Now if you're interested in this spot welder build, I've got a whole bunch of videos on the development and some of the accessories that I built for this, and I'll put a link up here or a card if you want to go back and have a look at those. But the very last one of these in that playlist was where I attempted to improve the performance of this repurposed microwave oven transformer. And there are literally zillions of videos on YouTube showing you how to repurpose one of these to create your own DIY spot welder. Now, when I first made this, I just copied the same technique that I'd seen by dozens of other YouTubers, where they placed two coils of heavy gauge battery wire through the secondary to give you around about 1.5 volts, but somewhere around about 900 to 1000 amps at the electrodes. And when I first built this, I tested it out and it worked fine, and I used it for a number of projects. And then somebody left a comment and said that you can improve the performance by, instead of having two turns of wire, just have a single turn of something really chunky, a very heavy copper cable. And the rationale was that you could get a much lower voltage but a much higher amperage. And technically, yes, that should be true, that should work. Now practically, when I made the upgrade, it turned out to be, well, it's not really a downgrade, it's more like a sort of a sideways grade really. But certainly it didn't deliver on the expectation that I had. And this is the new secondary that I made for the welder, and it's made of laminated copper strip. Cross-sectional area of these copper laminations were greater than the original cable that I had used, and the reasoning was that I would need more copper to take the greater current. So by way of apology, anybody who's copied that last video and thought they were going to get a performance increase, I'm sorry if I misled you. It just didn't work out for me either. So what I've done is I've gone back to the original configuration. So let's take a closer look. Okay, so in here you can see the next generation of this design, I guess you could call it. This is the cable that I purchased this morning and fitted into the transformer. When I did this originally, I used number 2 B&S battery cable, and B&S is brown and sharp. It's a standardized measure of cross-sectional area for copper cable, and with the number 2 B&S cable in there, it didn't quite fit in the openings in the laminations, and it was a bit loose and it rattled around a bit. I had to pack it with all sorts of stuff to stop it from vibrating. What I did this morning was I went and bought 00 B&S cable. So just to give you some idea of the increase in cross-sectional area, that's the original, the black one. This is the new one that I just put in. And although it's a huge improvement, getting it in there was a bit of a nightmare. As you bend it around and try and feed it through the laminations, it tends to bunch up and twist, and it very closely fills the space in the lamination, so there's not a lot of wiggle room to get it through there. However, the difference in welding quality is fantastic. So, I sort of understand the theory of why a single loop of cable would be better, but there's something else going on that I can't account for. Otherwise, this version that I made should have been much better. So let's just put this back together again and have a look at the improvement in the performance. If you want to go back and look at any of my previous videos, you'll see me welding together some thin sheet metal and some washers and wire and all sorts of things. Just with the few tests that I just recently, I've noticed that it's way better. So let's get it back together. I got that back together and that's running now. And when I did the original tests on this, I was welding together some galvanized steel and stainless steel. This stuff here is 0.6 millimeters. And if I just do a straight lap joint there, okay, and I'll just clamp that. Now I've got a digital timer on this spot welder, so you can set your weld time. Right, I'm going to set that to 0.6. We'll just see how that goes. Now, the test of a good spot welder is that if you were to try and peel that weld apart, it should actually tear a hole in one piece of material. So let's just try that. And I'm going to tell you right up front here, this is much better than I was getting from it before. So that has torn quite a sizable hole in one of those pieces of stock. So that was a 0.6 second weld. Before I wasn't getting a hole anywhere near that big, and it certainly was taking a bit longer. So the reason I'm doing this upgrade is that I'm doing another project at the same time, and I need to be able to weld this material here. This is 0.9mm thick sheet steel, and I need to weld this to some similar thickness of galvanized steel. And when I first tried this with the welder as it was before, with the single laminated copper secondary, it made some heat there, but it certainly didn't weld anything together. So a bit of a rush job to get this back together again and get the new secondary in there. This is some 1.8mm thick mild steel. Let's just try welding some of this galvanized steel to that. I might go a little bit longer here. We'll go say 0.8 of a second. And once again, that's pretty good. Didn't actually make a hole. Let's just try a bit longer. So I'll go 1 second. I'll go 1.2. Okay, it didn't make a hole, but it's certainly a strong weld. So let's put more than one weld on there and see how that goes. Alright, well I put 2 welds on there. And I don't know, for my money, I reckon that's pretty good. Certainly the project that I'm working on now is just really to locate some sheet metal so it can be TIG welded. So even without being structural welds, I think these are going to be absolutely fine. And you know, for a DIY spot welder, I reckon that's not bad. So, incidentally, I did go away and actually remove the oxide off that material just to give it a better chance getting a good electrical contact. I've noticed with this black steel or hot rolled steel that sometimes the oxide coating creates a bit more resistance than it should. Certainly cleaning it up made a big difference just then. So, in summary, for anybody who's thinking about building one of these, don't follow my example of using a single laminated loop of copper. That sort of was a bit of a failure. Certainly, if you're going to put 2 turns of wire in there, get the thickest wire that will fit inside the laminations of your transformer. Not only does it seem to give you more current, but it will also mean that the wires won't vibrate inside the cavity of the transformer laminations. And when I dismantled my original secondary, I noticed that it had abraded and worn quite a lot just from the vibration. This one with the new thicker 00 B&S cable is a lot quieter. You don't hear that rattle when it's running. So once again, all I can do is apologise. Go back and check out my other videos, but certainly have a look at what other people are doing before you make a decision for yourself. So for now, thanks for watching.